So we'll take a quick look at reviewing for test 4.4 through 5.4 part 1. All right, so the first thing is going to be, or something similar will be on there, is about solving a square root problem. Okay, it could be the kind of problem where you have two square roots in it. Okay, where then you have to isolate one of them and then square both sides. Or it could just be the kind of problem where you have a single root. Okay, let's do one where you have to isolate and then do it twice, so that covers both types. So let's say we have square root x minus 2 plus square root x plus 5 equals 10. Now, because I just made this one up, there's no guarantee that the solutions I get are going to work. Okay, so I have to check them. They could be extraneous. Okay, I don't know yet. All right, so what would be my first step here?
You have to isolate one of the sides.
All right, so let's isolate one of the roots, and how could I do that?
Subtracting square root of x plus 5.
Yep. So we can do 10 minus square root x plus 5. Okay, and keep in mind as we go through, it is possible my answers come out imaginary. If they do, at that point, I'll just have to stop. But everything we're going to be doing up to that point would be fine. Okay, it's just on the test, the answers will come out without imaginaries. All right, now what do I do on both sides? Yep, so we square both sides. Okay, and on the left, that's just going to give me x minus 2. And how about on the right?
It will be 100.
Mm-hmm.
And then 10 square roots, of x plus 5.
Negative 10 square root x plus 5.
Yeah.
Yep. And then what?
And then another one.
Another one, yep. So another negative 10 square root x plus 5.
And then
So how many is that?
2.
Negative
Negative
20. And what about my last term?
And then it would be x plus 5.
Yep, plus x plus 5. Right, so that's from foiling the right-hand side. And now we'll basically do the same thing again. Move everything to the left and then get the square root by itself. If we combine like terms, what do you get on the right side when you combine the constants?
105.
Yeah. So what I'm going to do is subtract 105 from both sides. And what else could I subtract from both sides? X. So that's gone. And that's gone. So that can happen sometimes. What that means is usually now we don't need a quadratic formula to solve it. I'm going to hope the answers come out okay.
She left. She left.
So what's negative 2 minus 105?
Negative 7.
107 equals negative 20 square root x plus 5. Okay, any questions so far?
Can you go over how you distributed the squares when you squared that?
Distributed? Yeah, so it's like FOIL. 10 times 10. 10 times negative square root x plus 5. And then another 10 times negative square root x plus 5. And then lastly, negative square root x minus 5 times negative square root x minus 5. That's the pattern. All right, so I was kind of hoping that I'd get a number that divided evenly in two, but in this case it didn't, which means I'm not going to get a nice answer. So divide by negative 20. And you know what, we'll round this off at the end. So I've got 107 divided by 20 equals square root x plus 5. Okay, what's my second to last step? Yeah, this is now a simple equation with just one root in it. Square both sides. So square and square root cancel. So I get 107 over 20 squared equals x plus 5. So what's my final answer?
What would you minus? 107 over 20 squared minus 5 equals x.
Yeah, whatever that comes out to. Which again, usually on the test the answer comes up nice, but I knew because I made this up, it wouldn't. Okay, let's find what that is as a decimal, okay, roughly, and check it. So we got 107 divided by 20, and we're going to square it, and then minus 5. So the answer is about 23.62. Okay, let me check and see if it works. Okay, what's 23.62 minus 2? So I need the square root of 21.62. It's about 4.65. And what's 23.62 plus 5? 28.62. And I need the square root. 5.35. And if I add those up, will I get 10?
Pretty close.
Yeah. So this answer is correct. Okay. Any questions on that? All right. So next one is a graph of a square root function. So let's try something like, let's do 2 square roots x plus 3 minus 4. All right, so just to make sure we know the transformations, how many transformations are happening here? 3? What's the first one?
Horizontal shift to the left.
Yep, shift left 3. Okay, so that's the first one. What's the second one?
Vertical stretch by a factor of 2.
Vertical stretch by a factor of 2. And the last one?
Vertical shift down 4.
Shifting down 4. Yep. All right, so now what I want to do is graph. Okay, the last one would have said solve.
Wait, what was the first one?
The first one was a horizontal shift left 3. All right, so now when we graph it, what's the point that you have to find first? Either for a cube, either for an odd root or an even root. It's the point that would have originally been where?
Origin.
The origin. All right. Now for an even root, it goes from that point in one direction. So that's like a start point. If I gave you an odd root, that's more of a center point. Okay, so odd roots look like, well, even roots look like that. Okay, they have a start point, go in one direction. Odd roots have a center, and then they go each way.
Are they symmetric on both sides of the center?
Yeah, they should be symmetric. Yeah. Can't think of, yeah, we can look at one after if you want, but yeah, it should be. So is this kind of problem going to have a start point, or is it going to have a center point and go in each direction? A start point. This is an even root. Okay, it's a square root. So to find the point that would have been at the origin, take the radicand, set it equal to 0, and that's your x value. So what's my x value here? Now, how do I use that to get my y value?
Plug it back in.
Yeah, just plug it back in. What's negative 3 plus 3?
0.
Yeah, we already knew that part. And then the square root of 0? 0 times 2?
0.
Minus 4?
Minus 4.
minus 4. So that is the start point of your graph. Okay, -3, -4. Okay, so I'll graph that point. And because it's a starting point, we're only going to test x's in one direction. So should I test x's that are bigger than -3 or smaller?
Bigger.
Yeah, it's got to be bigger. Because if you plug in a number smaller than -3, okay, like -10, you'd end up with the square root of a negative, and it's imaginary. So let's pick some values bigger than -3.
0.
You could do 0. I would do 1.
1.
Anybody know why I would do 1?
0 on the other side of the origin.
It's a reason because I want to try to do this in my head.
Plus 1 plus 3 is 1 you use minus the 4.
So 1 plus 3 is 4. And then what? How'd you get 2? The square root, yeah. So I picked a number that was a perfect square. So if x is 1, we get 4. Square root of 4 is
2, and then you get 4 minus 4 equals 0.
so 1, 0 is a point on the graph. What would be another good x value?
2.
6.
6. Yep, 6 is a good one. What's 6 plus 3?
9.
Square root of 9
3.
times 2
6.
minus
2.
4. 2. So 6, 2. Right, and at this point, I think I have enough points I can draw the curve. If you wanted to do some other ones, you could do -2 for x. That would be a good one. But does anyone need me to do -2? No? Okay. So just get your curve. Does it keep going in the other direction?
No.
No, because this is an even root. Even roots have a start point. They only go one direction. Right, so there's your graph. You really don't have to know too much about the transformations. All you have to know is, can you find a few points and then just connect them.
What would the transformation be?
If they asked you for the transformations, which they didn't, it would be shift, let's see, left 3, vertical stretch by a factor of 2, shift down 4. In that order.
Wait, what would be the order? Sorry.
Horizontal shift, vertical stretch, vertical shift. So that you will have a question, a separate question, not the same as the graphing one, where it says to describe how you could get this. In fact, I guess we could just do this as a separate question. I'll use the same one. All right. So let's say something like describe how to graph this, starting with this. And basically, you just list the transformations. Okay, so I've already said them a couple times, so can someone repeat them back to me? Yeah.
Horizontal shift left 3.
Okay, so shift the square root of x left 3. Yep.
And then do a vertical stretch by a factor 2.
And then vertical stretch by a factor of 2. And
Vertical shift down 4.
and then shift down 4.
Why aren't they those numbers? Do you know what I mean? So obviously the shift, you get it from x plus 3, like the 3 right there, right? The shift left, but then how do you get the vertical stretch and everything?
Vertical stretch is always the number that is in front,
Okay.
what you've multiplied by. And whenever you add or subtract a number, that's when it's a shift up or down. You could also write this problem like this. This is the same thing.
Why would that one be, why would -4 be like the shift? Oh, no, actually. Okay.
Does everyone see how what I wrote below it is the same as what's above it? There's no difference. Okay, so make sure you're comfortable with either way. Right? Make sure whenever you describe a transformation, you describe the direction and how much. So if you just said, I'm going to shift left, but you didn't say how much, then that would be wrong. Okay? And don't say something like shift left -3 or shift right -3.
So just positive.
Yeah, you always shift by a positive amount. Left and right takes care of the negative. Okay? Same thing with up and down. Okay, let's take a look at a exponential growth kind of problem. So let's say you have, I don't know, start with 50 bacteria. And it's going to increase at a rate of 2% every, I don't know, let's say 2% every 4 days. Okay. So increases at 2% every 4 days. Find a formula that represents the amount of bacteria as a function of time, in days. Okay, and then what we can do after that is we can figure out how long before we have, I don't know, 600 bacteria. All right, so what's my formula to find the amount of bacteria as a function of time?
A equals 50.
Yep, start with the initial amount times what goes inside here for exponential growth.
0.02.
Part of it,
So
Ooh, 1 plus R.
1 plus the growth rate.
plus
1 plus
So 1.02.
0.02, or if you just want to put 1.02, raised to the, what's the exponent?
T over divided by 4.
Right, because this has to represent the number of doubling, or whatever, the number of periods that were increasing by 2%. So if 8 days go by, really that's only one round of a 2% increase. Does that make sense? If, or to 2 rounds. If like 12 days go by, that's 3 rounds of 2% increases. Okay, so that's why you need the T over 4. Right, so that's the formula. And now let's figure out how long before we hit, what did I say, like 600 bacteria? Okay, so how long to hit 600 bacteria? All right, so type the formula in that we've got. So 50 times 1.02 to the x, that should be divided by 4. And what else should I type in?
And then 600.
600?
And then you gotta fix your window.
Yeah, I gotta fix my window. So the minimum number of bacteria is 50. I'm gonna max out at 600, so I'll go a little higher. All right, now I don't know how many,
You don't need an X-Men.
what's that?
I mean, you don't need an X-Men because you wouldn't have negative.
Right, yeah, I wouldn't go negative. The thing I don't know is the X max. I don't know how many days
20.
this is gonna take. So what I can do,
Oh, every 4 days.
if I wanna figure it out kinda quick, is every time it increases 2%, how many days does it take to increase 2%? 4 days. So that's 4 days, right there. After 4 days, you gained 1 bacteria. Now, if I keep multiplying by that, I'm just going to keep track of how many periods have gone by. So that's 1 period, 2, 3, 4, 5, 6. So it's taking a while. So I'm gonna set X max pretty high. I'm gonna try 700 days. I don't even know if that's gonna be enough.
Yeah, because 700 is 6.
For max and then min is just 0.
Yeah. Yeah, that'll work.
What would you put y1
Speed this
into?
thing up.
Wait, what would you put? What's y1? What's the equation for y1?
Y1 was the exponential growth formula, and Y2 was 600 bacteria.
Oh, it's just 50 times 1.02 to T
over
X.
4.
So yeah, so yeah.
So this is going to take, let's go second calc 5. So it's going to take about 501 days. Okay. Or if you wanted to know how many rounds of 2% increases that is, take 501 days and divide by 4. That's about 125 rounds of 2% increases.
Wait, how do you find the intersect? What is it?
Second calc intersect.
Do you not pay attention in class?
Oh my gosh, yeah.
What-
He says that one like 10 times a day.
What was the answer again? How many days?
501.
About 501 days. Okay, so there's definitely going to be a formula on there similar to that.
Can you write the original formula again?
The original formula?
Yeah.
Oh, just the general one?
Yeah, just the general one.
So exponential growth. How would you do it algebraically? With a logarithm. That's going to be the next class.
Okay.
So we know a little bit of information, but I don't know if we know enough yet.
Okay.
Okay, so exponential growth is initial amount times 1 plus your growth rate, but your rate has to be a what? Decimal. Raised to the t divided by, I guess you would call this the length of time for that growth rate to happen. Like in the last problem, it was 4 days. So length of growth rate, I guess. I can't really think of a better way to word that. It's the amount of days or hours it takes for the growth rate to happen.
That's it.
And the only thing for decay is you change it to 1 minus r. So actually I could do both. If I wanted, I could just put plus or minus, and that minus would be decay. Alright, so let's say I ask you to solve something like this. 2 to the 3x minus 1 equals 16. Okay. This is going to be kind of like one of the ones we did
Wait, what is
in
this?
the homework.
Exponential what?
This is just solving an exponential equation. Okay. In order to solve this, you've got to have the same base on each side. What's the base on the left? 2. And if you want, what's the base on the right? 16. So can I write 16 in terms of 2 somehow? It's 2 to the 4th. So now, in order for these to match, the bases have to match. And what else has to match? The exponents. Okay, so set it up and force the exponents to match. So 3x equals
3x equals 5.
5. And then x equals
5
7. Okay, the key is that I've got to give you, if I want you to do it without a calculator, you have to be able to write the base on the other side in terms of the base on the left.
When you tell us, like on a test, do it without a calculator,
Okay, so that's the answer. X
can't
equals
we
5.
literally still take, you can use a calculator?
I mean, you can use a calculator to solve that one, but the problem is, especially when it's a fraction, the calculator is going to give you a decimal, and I'm going to look for the fraction,
Remember?
if you know how.
That's like, how do you...
5/3 wouldn't be a hard one to convert because you'd see 1.6 repeating, but
I don't know how to do that.
Yeah,
if
no,
you
on,
if you ended up with a fraction like this when you did it on the calculator, like I doubt anyone's going to recognize that number. That's that's 2/7. So you're probably not going to be able to convert it on the calculator. So you have to know what I just showed you right there.
That was easy. Was it gonna be that easy on the test?
All right, so let's look at the next one. Okay, let's say I ask you to simplify something like this. Log base 5 of 125. What's one trick we learned when you have something in log form? What can you do with it?
Put it into exponential.
Hey, put it into exponential, but we're missing what's on the other side. So what could I put?
An X.
An X or a Y? Just put. Okay, put something there. Okay, if you change it to exponential, what's your base?
5.
5. What is your exponent? X. And what goes on the other side? 125. So I picked something that you can do in your head. So 5 to what power is 125?
5. The fifth power. No, it is not. The third.
Third.
Sorry.
Okay. Now what if you were solving it and you ended up with something like this? Let's say that was 1/125th instead. -3. Yep. So remember, negative exponent causes the fraction, causes your number to flip. Okay. So that's a good one. Let's try. Any questions on that one?
Wait, so how did you get the 3 for the X?
At this point, because we don't know any other tricks and we don't know how to type base 5 into the calculator, you just have to know
Sure, they
5
teach us this.
cubed is
Make it
125.
What if you don't? Like, how would you figure that out?
I'll have to give you one that you can do.
Like, one we would just know off the top of our head? Then?
Right. It wouldn't be like 5 to the x equals 126. You can't do that
Okay.
in your head. You can do it if you know how to type it in, but I haven't taught you that yet.
Sophie probably knows.
How about, let's say log base x
What is 2?
of 15 equals 2. All right.
That would be tricky.
How would you solve that one?
Turn it to exponential.
Yep. And what would you get if you change it to exponential?
X squared equals 15.
X squared equals.
Oh,
And how would you solve it?
No.
That would be less than 4, just under 4.
I don't even talk in class. I literally don't talk in class.
I know, you never
I'm talking
said it.
now. It's just accepting my good book.
Wait, what are we? Oh, so x squared is 15.
Yep.
So you would,
So you have to find x. Would you?
you would
You would find the square root of 15.
square root of 15.
Yes, you would. Square root. And x is whatever the square root of 15 is. Just type that in and see what you get. Right. So we did one where the variable was in the base. We did one where the variable was on the other side. Let's do one where the variable is the argument now.
What on Dora said.
Let's try log base 2 of x equals 5.
Would you do it to exponential?
Yeah, change it to exponential again.
2 to the 5th.
32. Yeah, so x is 32. So make sure you know how to solve log problems where the variable could be anywhere. On the other side, the argument or the base. Okay, any questions on that? Okay, and I think that pretty much covers everything that's on there.
Yeah.
Are we gonna have to do that thing where, like, you know how you gave us all
to combine and split logs.
Yeah.
There might be a bonus question with that.
Okay.
Yeah.
Can you go over,
And there's multiple of each type. Like there's probably multiple with variables in the base and multiple ones with the variables in the argument. Because we only did 2.5 sections.
You just did show us?
Some of them, yeah.
What would be like a hard one? You know what I mean? Like,
Probably the hardest one we did today. Maybe this if you don't know the graphing calculator or the formula.
Yeah, I don't know.
no, I'm saying like, what would be like a hard like law problem? You know what I mean?
It doesn't get really any harder than what we did here.
Okay.
Yeah,
Mr. Hager, can you just go over?
this one's long, but it's a radical problem. Not
Wait,
about
what?
that.
More of a class did you please?
Yeah, Bree, what's up?
can you just go over how to do the graph, like?
The graph of
how to
a
graph, like, I know how to get the starting point and the center point, I just don't know how to graph, I was kind of zoning.
so to graph.
Like, to find the other points still.
I'll just do a simple one. So if you want to graph that, you get the starting point, which is 2, 0. You know how to get that?
Yeah.
Okay. So you got that.
Wait, how do you get 2 0?
Now to get 2, 0,
Yeah.
set the radicand equal to 0 and solve. And then to get y,
Just plug it back in.
plug it back in, and then simplify. So you get 0. So this is 2, 0 for the starting point. And now to get the other points, just pick some values for x and plug them in. You can pick anything you want that's above 2. But I would pick 3. Because what's 3 minus 2?
1.
And the square root of 1?
1.
So that's an easy one. What about 6? Let's plug in 6. What's 6 minus 2?
4.
And what's the square root of 4? 2.
6. 2.
Yeah. And you could do, now 11 would be off the graph, but that would be a good one to do, because what's 11 minus 2?
9.
9, and what's the square root of 9? So 11, 3. Maybe about right there. And that's how you get your points. If it's even, you only need to check in one direction. Odd, you have to check both.